everyone. I'm Susan Nash, AAPG, and I'm really excited that we have a wonderful presentation today. And this is for AAPG, but also on behalf of Tulsa Geological Society, and AAPG's Division of Professional Affairs is also supporting this. So really excited about how to basically learn about formation damage treatment, which is something that I know all of us have been interested in, especially with older wells. And so this is exciting. This is by Commit Well Solutions. And we have two presenters today. We have Ivan Moen and also Rebecca Teixeira. So anyway, I'd like to get started. I'd like to invite you to share your screen and get started.
Sounds good. Thanks so much, Susan, for putting this together and to AAPG for allowing us to present today. Can everybody see my screen?
Looks great.
Perfect. All right, so today we're going to be talking about maximizing production recovery through innovative formation damage treatment. But before we really dive into that, I want to just kind of set the scene really quickly. So over the last several years, we've seen individual wellbore performance really improve as a result of advances in drilling and completions technologies. But you can see, at least from a macro level, we've seen that that's starting to kind of tail off and perhaps even decline as a result of us running out of prime drilling locations. And when you combine that next to us drilling wells so much closer together, Schlumberger is showing that 64% of parent wells are experiencing some level of fracture-driven interference, or in common terms, frac hits. And we know that with frac hits, we can see production go up, but we can often see production go down as well. And we know that frac hits cause formation damage to offset wells. And you take those two things and put them under the heading of the new focus of our industry to get away from just driving and increasing production at any cost through the drill bit, just drilling more wells, to this focus now on capital discipline and operators needing to return cash to shareholders and operate within free cash flow. Put all that together with a growing inventory of mature shale wells, and there's a drastic need for us to really focus on sustainably improving recovery from existing wells. And so how do we do that? Well, today, the data from Kimberlite shows that the most frequent reason that wells are underperforming is due to formation damage and or debris. It can be one or the other, oftentimes both. We see it being both. And so with that, today, the most common solution is operators just using some form of acid stimulation, which we know can come in many forms, but the most frequent common form we see is just bullheading acid from the surface down the backside of the production tubing. And there are inherent limitations and challenges with that. You're not sure that you actually even treat the entire wellbore as a starter. And so with all of that together, we've thought through the things like, how do we choose the right candidates? And how do we make sure that we're choosing a treatment fluid that's actually going to address the underlying problem? What is causing the formation damage to begin with? And so Commit has put together not only an isolation system that will ensure that we're able to treat the entire wellbore, but we've also thought through the workflows that need to happen on the beginning part of that. Choosing the right candidate well, making sure that we understand what the formation damage, what the cause is, and choosing the right treatment fluid to do that without just assuming that the correct answer is acid, obviously. Making sure that the wellbore is cleaned out of any debris, and then coming in, at the end with our isolation system to treat the entire wellbore. And with that, I'm going to turn it over to Ivan now, and Ivan's going to dive through the individual details of all of those steps leading up to it, as well as show you some case studies that will really drive home the results that we can help create for you.
Yeah, thank you, Rebecca. So at a high level, obviously, what we'll talk about is production enhancement through doing interventions on a wellbore, and I think on production enhancement, what we're basically thinking about is adding back production that is lost for whatever reason. So a wellbore that is not living up to its full potential. And so I think the first question we need to ask ourselves is obviously, if we're treating a well, what are we treating for? And formation damage can come from a variety of sources or reasons. It can be from the filter cake, from the drilling of the wellbore, from the completion fluid that's caused damage to the fractures, and ultimately near wellbore damage of the well. And then you have scaling and these kinds of things that happen as oil migrates its way into the well, and scale is precipitated as we as we have a pressure loss when the oil enters the wellbore. So there's a wide variety of backgrounds kind of for why we have formation damage, and I think as Rebecca mentioned, and also showed the statistics on right, the most popular way to treat near wellbore damage has been doing some sort of acid stimulation, and that's great when acid is the appropriate cure or appropriate treatment, and then obviously if it's not, then we need to do something else. And so figuring that out up front, what are we treating for, is quite key. And then the next question at that point becomes, how do we treat? And the most predominant way right now in the industry is the bullhead treatment from surface. And it's, simple, easy way to do this. It's, low cost. It requires the least amount of preparation, or least amount of operation involved. You typically don't even need a workover rig. You just bullhead down the backside of the production tubing. So it's got its obvious benefits to do so. And at the same time, it comes at the trade-off, which is lack of control. So I think as our wellbores now, we have, our laterals get longer. With modern day completions, we have hundreds, if not even sometimes over 1,000 open perforation clusters in a lateral. So, and fluid tends to take the path of least resistance through there, and so it's difficult to effectively divert treatment fluid through across the entire lateral to make sure everything gets treated. And on the other side of the equation is what we call focus restim, which is using a isolation system, dividing the whole lateral up in many, many zones, and then doing one zone at a time to make sure the entire lateral gets treated. And so product placement is the obvious benefit of this. At the same time, it's also the most involved process, right? In this case, we need a workover rig. We need to take the tubing out of the wellbore, do our clean out, all of these things. So it's a much more involved process. And so I think basically the next step of the equation is, is figure out kind of which method is appropriate for each well. And I think it's, from my perspective, I think it's important to keep in mind I think there's a home for both, right? I think, and it ultimately comes down to doing our homework up front and quantifying, how much production can we effectively add back to a wellbore. And if that number is a lower number, doing a bullheading treatment may be just fine. I think from an strict engineering standpoint or strict technical standpoint, it may not be the perfect treatment in that we only treat a certain percentage of the lateral, but at the same time, economically, they may be just fine. At the same time, if we just kind of for argument's sake, assume that each foot of the lateral produces the same amount of hydrocarbon, then basically, to fully restore something, then if we treat 50% of a lateral, then we should recover 50% of the uplift potential, and so forth. And so if that number, that we can add back starts being a larger number, at that point, we're also running the risk of leaving essentially a fair amount of production on the table, and with that leaving a lot of value on the table if we don't treat everything. So on the other end of it is when a focus restim would come in and maybe be the more appropriate way to do this. So all of this basically forms what we call the Excite platform that we work from. So if we think about, production enhancement through doing some sort of intervention, the entire process leading up to it, if we put it into essentially 4 main buckets, starting at the candidate selection, right? Finding wells that are underperforming and determining why they're underperforming. And then to the next step, figuring out, if these wells are underperforming, how do we treat that and how do we bring production back to where it should be? And I think if we draw a line kind of down the middle here, the left side of the equation becomes the homework up front, and the right side of it becomes the operational execution of it, which is treating the well, or initially cleaning and prepping the wellbore, and then at the end of it is the treatment execution or the treatment placement, essentially making sure that the entire well gets treated. And so I'll dig in a little bit more on the candidate selection side of things here, because I think this is really key, and this is a classic well profile that we would work on. It's kind of like I talked about earlier, right? I think with what we're discussing today, we're very much in the production adding back business, and so here's a wellbore that's doing what it should be doing until at some point it's not. And so here is like, why is this wellbore underperforming? Figuring out the root cause of that, and also figure out the appropriate treatment for it. And all of the data we have, so we track production, all the wells we have treated using this approach. And I think all the data we have on this suggests that basically if you can treat the whole lateral, your original forecast of the well becomes a very good guide of essentially what we can, on a sustained level, add production back to. And then if we're not treating the whole lateral, then we're adding back a certain percentage of that. So if we treat 50% of the lateral, maybe we can add back about 50%. And so then it's important to have a way to add, or to quantify how much can we ultimately add back. If this is 5 barrels a day or 10 barrels a day, then doing a bullheading treatment here, maybe even leaving it alone, may be just fine. If this is 50 or 100 or several hundred barrels a day, then like we talked about earlier, at that point you run the risk of leaving a substantial amount of production on the table if we don't treat everything. So doing this up front is really key to be able to make this whole process work. I think it's one of those where if we don't get this part of it correct, it doesn't matter how successful the operation is. And if the operation, because we can have a great operational success, but not so much on the economics. And so the whole thing kind of needs to be linked together. So doing this at the individual well level, that's all fine. Most of the people we work with tend to have more than one well. And so looking at, finding a way to effectively screen this, right? If you're working with clients that have hundreds or sometimes even thousands of wells, it can be a daunting job to go in and start looking for underperforming wells at the individual well level. So what we're working on and what we're about to launch then will be an app to do the initial high-level screening of this, where we look at the remaining reserves in the well, we look at the decline, which we basically look for wells that have exhibited a larger than normal decline, but they still have a large amount of production potential in it. And so tiering this, basically what we want to go after becomes the wells that are in the top tier, basically well bores where we can add back a fair amount of production and that has a lot of life left in it. And what we want to avoid is to treat wells that fit in on the other side of the spectrum that are either depleted, there's limited uplift potential in these things. And if you can take a large number of wells, right, and then kind of scale it down or funnel it down to where on the other end of the funnel, you have a just like a manageable amount of wells you can start doing more of a deep dive into, and then ranking those again. That becomes a lot easier to make this whole thing work at not just the individual well level, but also a little bit more as a process or at the program level. All right, flip 1 to 4. So then talking about moving on to the Excite system that basically once we've done worked everything up until this point, making sure we get the whole well treated, treat the whole lateral, make sure we can remove effectively formation damage, whatever the source of that may be, is when we go in and use our isolation system. So what we have is it's a dual packer style system where you can space packers out to accommodate essentially any spacing downhole. So with that, you can go in and isolate your original frac stages. You can do 2 stages in one. You can focus energy even more. And so the whole point here becomes dividing the whole lateral up in many zones where you treat one at a time to remove formation damage. And so you run this in on a tubing string, typically using a workover rig, run to the bottom of the wellbore. The system is activated by hydraulics, so you just pump down the tubing, it activates, you stop pumping, it unsets. So it's a pretty smooth operation at that point. There's no moving the tubing up or down or rotating or anything like that to make it activate or set and unset packers. It's pump to set it, you stop pumping, it unsets. So you just run to the toe and work your way. Doing a quick animation of how this ultimately works. You have all your components here. You will be pick up on surface, like we talked about. You just run the whole string in on tubing, typically stick pipe, sometimes coil tubing, and then run to the bottom of the wellbore. And once you position the system across stage one, you pump down the tubing. That will shut the flow through the tool off. And that will activate the packing elements, which in this case, you have the bottom element here, top element higher up. Then you have a port in the middle. So at this point, you are isolated in one zone only. The fluid comes out through the port. You basically treat that one zone. And like I said, this can basically be any kind of interval you're looking at. But let's, for argument's sake, say that as your, your one frac stage. Treat that, move up to the next one, and keep going like that throughout the entire lateral. Another key to this too, right, is to, we had a few gauges show up here. So as we keep treating throughout the lateral, we run memory gauges on the system. So you have your pressure and your temperature is being measured between your two packers in the zone you're treating at any given point. And then you have the same above and below as well. So as you keep moving through the lateral, as you keep treating, you also essentially log the well. So you get the injection pressure at each zone, which gives you also a good feel in terms of level of depletion of each of your stages. And then you also will have a map of how efficient the treatment was. So sometimes what happens is you pump into one set of perforations, and then there's communication behind pipe. So you see some of the treatment coming in above you or below you, and that will be picked up on the other gauges. As you come out a hole and as you keep treating, you also, like I said, you basically can create a map afterwards of your pressure regime downhole and also how efficient the entire treatment was. And I think for us, this is really key because most of these kinds of operations, most of these kinds of treatments tend to be done solely by using surface data. You have that data on your pump, you have your pump pressure and everything on surface, and maybe you have your weight indicator and stuff on the rig, but everything is on surface. You don't know exactly what's happening downhole. And at the recent presentation from SLB, they talked about basically how the success rate of interventions at the industry level has remained constant for about two decades. And one of the main reasons for that is that we're not effectively leveraging downhole data in our operations. And from our standpoint, we can really speak to that as well, because I think we've learned so much about exactly what's happening downhole by just having essentially a set of eyes through the gauges and being able to see exactly what happened throughout each treatment and each job. And I think there's even examples of things that look perfect on surface, and we'll look at it downhole and something else had actually happened versus what we had assumed. So collecting this, it's a good way to, you get a lot of good data out of it. One, it's a good way to confirm your operational success, but then also for future learning and implementing, and even, there may be different ways to treat your well looking at the data as well. So let's go into a couple of case studies, kind of summarizing everything we just talked about. I think the first case study we'll have, this is from the Midland Basin, and this really hits home basically everything we talked about, from candidate selection, the proper treatment, and then also evaluating the economics of this, right? So here's a wellbore where we had, after about 75 or so days, we had a fairly pronounced drop in production. Roughly 150 barrels a day or so was dropped kind of from the trend. where this well was headed. And in this case, this is scaling, which is something our client here is seeing quite a bit in this field. And their standard operating procedure is to treat it with acid. And so we talked about earlier as well the various methods we have available. And so in this case, the operator here bullheads acid down the backside of the production tubing and gets a very nice spike in production. But then the decline is quite sharp as well. So I think the good news is here, I mean, the treatment is working, the well is responding to the treatment. But the bad news is looking at the decline, we're basically, there's still a lot of damage left downhole. We did not effectively treat the entire well. So in this case, we prep the well, run in with a isolation system and start treating all of the, in this case, 26 frac stages in the well, making sure everything gets treated. And so we're lifting production back up and also looking at the decline. We're basically back to a much shallower decline. It's a very sustained uplift. And so I think in this case, it's quite indicative of that everything, you know, all the formation damage here has been treated. And I think if we can kind of move this production back to right when the drop happened at this point, would basically be just following the original forecast of the well. So this is a great example of, it's not too often we have these where you have multiple methodologies on the same wellbore, so you get a good side-by-side comparison on that. But I think also digging into this a little bit further, right? If we look at the candidate selection, I talked a lot about quantifying that uplift. So I think in this case, I mean, we have a pretty pronounced drop of about 150 barrels a day. And I mentioned earlier too, like all the data we have is on a kind of longer sustained, at the sustained level, getting back to that original forecast of the wellbore, that becomes a really good guide of what we can ultimately achieve, assuming we can treat the wellbore effectively. And so in this case, adding back roughly 150 barrels a day or so is kind of what we're playing with. The economics of that, I mean, adding back 150 barrels a day, that's a home run. That's a lot of added production. So if we start quantifying this, and now we have a year data on this wellbore, so we can start quantifying this a little bit better, right? I mean, one option is to do nothing, is to basically take the production down here and just kind of make some assumptions on how it's going to produce over the next year. And then we have our bullheading treatment here, which certainly got a very nice uplift, and then but also quite steep decline. And so making some, kind of extrapolating that decline further out. And then ultimately we had a focus restem where we got production up some and a much shallower decline. So looking at this from a production after 1 year standpoint, I mean, we have numbers that look something like this, right? And then ultimately, I mean, in this case, doing a focus restem will add the most barrels per day, but then you always also have to ask, what's the cost of this? Like we mentioned, I mean, doing no treatment costs nothing. Doing a bullheading treatment is the cheapest kind of intervention you can do. And then a focus restem is the most involved intervention you can do. So, in this case, it makes very good sense to actually do a focus restem, considering how much production you can add back. But if we kind of were to take these numbers and divide them by 10 to where we're adding back 15 barrels a day, the economics here will be way different. And that, going back to what I talked about earlier, at that point, a bullheading treatment like this may be fine, or even leaving it alone may ultimately be fine too. And so this becomes really key to make sure that this whole process work is to be able to accurately predict this and have some confidence behind that that production uplift we're predicting is actually going to happen. Here's another example. This is from the Mississippi Lime, and this is Rebecca mentioned this earlier as well, from fracture-driven interference. This is public data. This one is the actual production data from our client. In this case, this is the public data from this wellbore. But we have a well that's in this case got frac hit and initially lost all of its production. And here, our client here did a treatment, cleaned out the well for all the sand, all of that, bullheaded some acid in, got some production back. And kind of looking at the original forecast, I mean, we're getting some production back, but it's also basically taking a haircut in terms of overall productivity of the well. I think our client here had estimated they were lost essentially 40% of the EUR of this well. So here too, this is a completion with 30 original stages. And after some time, we shut it in, went in and treated all the 30 stages in this case, and then got production lifted back up. In this case, I forgot to put on the y-axis the actual barrels per day here, but in this case, that represented about 100 barrels a day added. And so then this makes really good sense. Again, if those numbers are lower, then something else may be appropriate. So, but in this case, since there's a good uplift potential, we'd potentially be leaving a fair amount of production on the table by not getting everything treated, and also able to add back essentially the original EUR on the well. And I think the final slide I'll show on in terms of case studies. This is solely downhole data. This is nothing else. There's no production on this one, and this is a unique case because it's older completion, short lateral, only 4 original frac stages, but then 4 perf clusters per stage. And here for this one, we came in. So obviously on the original completion, all 4 clusters were fracked all together, right, in one stage. In our case, we came in and isolated each cluster individually, and then did 16 individual acid treatments on this one. So I'm showing here, this is the peak injection pressure that it took to inject into each one of these clusters. And I think it's pretty neat to see. So that, going back maybe a little bit, that will be the pressure that's recorded right here between the 2 packers. So I think it's quite neat to see in this case. I mean, you have a variance of, whatever, over 4,000 PSI from cluster to cluster. And I think within each stage too, you start seeing quite a pretty good evidence of maybe dominant clusters from the original frac that are quite depleted now versus clusters that were maybe not really broken down or took a lot of treatment or stimulation on the original frac, which essentially exhibited virgin rock-like behavior. They took a lot of pressure to break them down. Acid would hit, the nice acid break, basically treated like new rock. And so also kind of talking about on the bullheading side that we discussed, right? It will ultimately take the path of least resistance, even using diverters and these things, which will certainly help some, but diverting effectively this whole lateral becomes challenging. I mean, if a bullheading treatment makes it in here, probably doesn't make it a whole lot past the seal stage, which is quite depleted. So like I said, if we treat each stage individually, we still see a lot of variance throughout the lateral, but this one is quite neat in that we can actually have the injection pressure for each individual cluster, which on a new completion, that becomes challenging when you have thousands potentially of perforation clusters, but on some of these older ones, that becomes a pretty good option. So I think just to kind of, I'm running out of slides here, and I think we're about halfway into the allotted time, so we can open up for questions afterwards. But it's kind of wanted a high level. This is across the United States. These are the areas where we have so far applied this platform. Pretty Permian Basin heavy. Been a fair amount of jobs in Oklahoma. Of all places, in Bakersfield in California we've done, and then some North Dakota and some stuff in the Marcellus as well. We track production on all the wells we do, and for the most part, that's on public data. Some of that is great, some of it is not so great, so it is what it is. But I have a snapshot here across the entire track record of the wells we've treated, and kind of 6 months leading up to a treatment, 6 months after. I think just on the public data, I think it's neat to even see here, basically, we have a downward, even the public data is picking that up, like a downward slope leading up to a treatment. So again, back to what we're talking about, we're targeting underperforming wells. And then following a treatment, we have a quite sustained uplift, which is quite indicative of that we can get, as long as we can get everything treated, we have a good chance of basically recovering all the lost production of a well. It's been, I think we've been running the system now since about 2018 or so. Definitely a steep learning curve in the beginning, as I think with all new technologies, but this we almost started on the wrong end of this. We started developing a isolation system, and then everything else we talked about is essentially, all of these years of learning, figuring out candidate selection, figuring out these things, prepping the wellbore properly, and ultimately running an isolation system, getting everything treated. So all of that is contributing to a very strong track record at this stage. and just applying all the learnings that we've had over these years. So I think with that, I'll probably open for questions.
That sounds good. We do have a question, but I have one before we get started. So we talk about formation damage, and I don't think we ever really went into detail about the different kinds of formation damage and exactly how it happens, and why there shouldn't be just a one size fits all approach to it. So could you identify the different types of formation damage and what causes each type?
Yeah, I think I talked about it a little bit at the very beginning, but it's
Yeah, but let's go into more
making
detail.
making an analogy of it. It's if you're a doctor and you're treating a patient, you gotta, you need to figure out what you're treating for, kind of thing, right? And then ultimately, if there's nothing wrong with the patient, you shouldn't treat them. And it comes a little bit on that with this too. I think I mean, scaling is quite common. Which happens, many parts of the oil field, and various types of scaling too, which tends to happen as oil is produced, and throughout the pressure drop at the very end before it enters the wellbore is typically when scaling tends to precipitate from the fluid. So that's quite a common thing. Maybe not so common, or actually it's still quite common too, is like formation damage from a frac hit, where and that can be caused by a lot of things, really. Sometimes we have examples of a child well like just scaling up a little bit from a frac hit, with other times of fines migration. These things, all of this is going to require different kinds of treatment. If you have damage from the original, we have, and I think as an industry, we've definitely gotten better at it. But on some of these older wells, there's still a lot of damage left from the completion fluid that was used. So that's impeding production downhole. So figuring out,
Right.
finding each, what's the matter with each one, and then doing that analysis. Sometimes we work with a client that has a lot of experience from one certain part of the field. I mean, say they have, we know it's iron sulfide. For us, it's basically a matter of getting it properly treated. And other times we have to do a fluid sample analysis and these things, and try to figure out exactly what's happening before we actually go figuring out treatment, and then ultimately go treat it. And I think
Right.
also
And
kind of what we really want to maybe kind of one main reason behind this whole platform too is to make sure that we don't just treat everything as one. Sometimes acid has been a little bit of a be all end all kind of treatment, and that's great when that is the appropriate treatment, and other times it's not going to be effective. So it's important to do this up front.
well, I think that one of the things that I've noticed in one major reason for formation damage is the wrong kind of fluid. So you really need to know the you have to do some geochemistry, which was interesting. What you're saying is like, so specifically, like if the pH is wrong, you can get this swelling in some of the clays and the clay minerals, or if you and like you said, it could cause scale, but there there can be some other issues as well. And I'm just wondering what types of tests you do to really determine.
Yeah, I think from our standpoint, so our expertise tends to be more on the hardware side of this. I think everything else that we work here, basically developing a process, it's becomes a little bit making sure it is being done. So we have some experience on it, but we also tend to work a lot through partners that do, depending on which part of which field, whatever we're in. We'll work with labs, we'll work with the service companies, and these things to make sure we figure out specifically what's the matter with each. What we're treating for in each specific well.
I like that. That's really great. So your tools, like you can deliver anything. Okay, so I'll get to the questions here. It just fascinates me as a formation damage stuff because it can happen during completion, but then it can happen over time during production, and like you said, it can also happen through development and offsets, and it's always like suddenly you go, oh, what happened? and then and It's not depletion or decline's not due to depletion, it's due to formation damage, as Rebecca pointed out at the beginning. Anyway, and you've pointed it out too. Okay, so Parabach asks, is it possible to apply this Excite system and acid treatment in deep, hot HCHP wells or reservoirs with above normal content of CO2 and H2S? Has it been pilot tested in such an environment, and where? Thank you.
Yeah, short answer is yes. So I think going on the specifics of that, I think we can treat up to, or we'll enter wellbores up to 350 Fahrenheit. On the pressure side, we're good for up to 10,000 psi differential, and that's actually quite neat. Since I mentioned we have the downhole gauges on the system, and so we can see after it becomes after the fact, but we can see that, you know, specifically how much differential we've exerted on the packing elements, and a lot of, you know, so much equipment in our industry that is 10K rated, and very often that's not needed. And very often when we treat, it's very often a lot less than 10K, but we do have some examples too when we go to a true 10K differential downhole. And so it's obviously been tested and qualification, you know, in a lab, but we also have actual downhole data showing that we've taken it to 10K, kind of in the real world, if you will. So in terms of, yeah, CO2, H2S, these things, I mean, that's also possible. We treat that a little bit as a, I know, kind of case by case basis in terms of concentrations and these things. It can obviously have an impact on metallurgy. It can have an impact on elastomers. So we just kind of make sure we do our homework on that up front before we run into to avoid any issues on that. But yeah, I mean, the Permian Basin has a lot of areas with H2S. We also work in the North Sea that has areas with H2S, high pressure, high temperature. The highest pressure we've seen is, of all places, been in Bakersfield in California, where we've actually gone to 10K differential downhole. And so kind of a winded answer to to say yes, it is possible.
That's great. Okay, so I suspect that, well, Francois Marichal is saying, can you identify drill fluid damage?
Yeah, and I think that becomes a little bit more, you know, let's make sure we do all the tests up front to before we do any kind of treatment. So if you suspect that, I mean, let's look at the fluids, let's look at these things, and get the samples we need to try to determine it. And the analysis itself will not be done by us, but probably be done by one of our partners. But we'll be very instrumental in making sure that at least we try to identify specifically what's the matter with each well, because that really comes from earlier on in our life, where we had a lot of operational successes in these things, but not always so many. The uplift was quite spotty in that sometimes it seemed like we treated the treatment we did seemed to work, and other times it didn't. So we're definitely going to make sure that we, you know, find out what's appropriate for each one.
That's good. Okay, this is great. We've got some questions, more questions. Have you experienced formation damage from barite using a drilling and completion fluid? And if yes, is acid the right solution, or is there a better solution?
Yeah, I think the barite, I think stuff we've done with that, I hope I'm not a shaky ground here, but I think the stuff we've done with that has been like the converter style, where you'd basically pump a converter initially, and then you come back and do and dissolve that with acid, and treat it that way. And so yeah, short answer is yes, that's been done, but like it becomes a two-step process, because just hydrochloric acid typically would not work on that. You need to convert it into something that's going to dissolve.
Excellent. Okay. Some treatments or frac jobs seem to be associated with seismicity, but most don't. Do you have any experience with that problem?
I'm sorry, I'm not sure if I quite understood the question.
Gary, do you want to open your microphone and ask? Feel free to unmute yourself, Gary, and open up your microphone and camera. Let's move to the next one.
Yeah.
Please describe the criteria and mechanism for pricing the tools. And are the tools typically integrated into the pricing of the entire treatment?
Yeah, I mean, it's difficult to give a very specific one on that, but that may be better done offline. But I think give a little bit of a general answer maybe on it. I think um, you have, like I mentioned, on one side you have bullheading, which is a pretty cheap way to treat. Obviously, with its pluses and minuses, and then on our end, which is the more involved side of doing this. So by doing this, the focused restem approach, you need a rig, you need to take the tubing out, you need to clean out the well, and then ultimately treat it through running a system like we have. And so that becomes a bigger, the investment of doing that becomes substantially bigger than doing a bullheading treatment. The ultimate cost of our system becomes a very small fraction of that whole overall thing. So for our clients, it's been a much, been more of a case that, make sure, make sure they're comfortable doing that investment to do a focused restem more so than our kind of smaller portion of that total cost, if you will. So that becomes more the decision to do. Do you bullhead or do you do the clean out and the focused treatment approach? The tool itself is ultimately, like I said, a fairly small portion of it all.
That's interesting.
We have,
So,
I think on here, I think, sorry to interrupt, but I think we have
oh, you did.
Rebecca, her contact information is here. So again, certainly, price out specifics in these things that she would be the one to handle that. But yeah, like I think anyways, apologize for like a generic answer, but I think that's the best way to maybe look at it. It's kind of the holistic cost of each application and which one is appropriate for each well.
That makes sense. So, thinking about the future, what do you see as sort of the emerging challenge or emerging challenges?
Yeah, so I think the big thing we've seen, so I think some of the things that Rebecca showed here earlier too is that timing for these kinds of treatments, timing for production enhancement through intervention has, I don't think, ever been better in the shales. I think at the macro level and on so many, at the investor level, everything is basically lined up for this to be more attractive, and we're certainly seeing that as well. A big challenge, and which is why we're going through all of this, even developing an app and help our clients further, is to have a process that is precise, right? So I think if we're looking at a wellbore, if you have a lot of uncertainty of how much production we can add back to it, then it makes sometimes more sense as just bullhead and see what happens. It's cheaper to do, and let's just see what happens versus doing a larger investment and treating everything, from an engineering standpoint, doing this better, but not always financially. So big challenge that we've been working on, and that the reason why we're going through all developing this app and doing these things is to be able to do a lot better, get a lot more precise in terms of quantifying that uplift, and at that point having some confidence in it to where our clients can make a lot better and a lot more informed decision about which way to go.
Exactly. Well, and one thing I think is very critical in this is that as you do this, you're gathering a lot of additional data. And so that data can be used not just for this one treatment, but for the future and future decision making.
Yeah, absolutely. I think like reservoir engineers love this stuff. I mean, the data, because I mean, they learn so much about the wellbores, and we've even had some clients running this more or less solely for the data, could almost like kind of calibrate their models and stuff. So it's that portion of it. It's a nice kind of added on from doing this kind of an approach for sure.
Yeah, that's great. Gary, if you happen to be still here and would like to open your mic and ask the questions for clarification, that would be great. Let me see if he's here. I don't see him. But at any rate, does anybody else have any questions? Well, I noticed that Gary's gone already, so maybe he had another commitment. But I would think that this is just my perspective. But since you're not, I mean, since you're not really doing a huge frac, I mean, I can't imagine what the seismicity might be, except potentially if the flows increase so much that there's a lot more fluid to.
Yeah, I mean, we rarely fracture the formation here. I think in this case, we're kind of pumping into existing fractures in these things. So yeah, I
Yeah,
mean, if
yeah,
that was the question, we certainly never, or not never, but yeah, we rarely kind of fracture the formation by doing these treatments.
right, right. Is if anything, it's just cleaning them up and increasing flow. I can't imagine that it would increase flow to the point where you'd have enormous additional produced water or anything like that. So I just, yeah. But at any rate, oops. So I think it'd be great if you have additional thoughts too about the parts of the country that you think are just sort of ripe for this type of approach. Besides, say, West Texas. Oh, here we go. How do you handle bacterial scaling that is recurring after treatment?
Yeah, I think on that is we don't want to obviously with the water with the water we do pump throughout an operation like this, we don't want to make sure we don't cause future damage from that. So making sure that is treated and something we'll work with the chemical vendors and these things to make sure we're pumping something that's compatible at all times. So we want to make sure we remove whatever damage is there and also make sure that we don't add any damage back to the well if that makes sense. So certainly that's something to consider as well. And I think yeah, I think also maybe we make a comment on geography on this. I mean, Permian has been quite a pretty busy area for us, but I think basically, I mean, anywhere where you have any kind of scaling or anything that's causing wells to underperform becomes candidates for this, right? And I think that's ultimately, anywhere where that is an issue, that those are all the candidates. At that point, it becomes a matter of quantifying this properly and doing that homework up front, and then go out and determining which way is appropriate and kind of go from there. So yeah.
That makes sense. And then I guess thinking about bacterial scaling. So in theory, your system can deliver all kinds of things. So potentially it could deliver biocide as well, right?
Yeah, for sure. Yeah, and that's you know, after each treatment, if say you pump with acid for argument's sake, and then you got to displace that down. So you displace it down with water and make sure that water is treated too, so it doesn't cause any additional damage.
Yeah, that's great. Well, looks like we're finishing up a little bit early, but that's fine. So, if anybody has a question, another question, this is your chance. Well, I have another thought. Okay, so do you find it's easy to work with small clients as well as big clients?
Yeah, I think I think everyone kind of have their different needs, right? I think from our experiences that and it's not this is general. There's been so obviously variances from company to company, but a lot of the bigger clients very often have their own process in terms of I mean they're quite on top of things in terms of identifying wells that are underperforming, doing these things so they don't need so much help on that side of it. They just need help on basically the placement of the treatment, and then the maybe on the large or extreme end on the other side is working with smaller clients or maybe clients who just bought a lot of wells and acquired a large portfolio and don't necessarily know exactly what they have in terms of do we have wells that are underperforming and or not. Then that's where the app that we showed that's being launched soon, something like that could really help. At that point, you can at least take the entire portfolio you have and let's condense it down and start looking at specifics on just a handful of wells to get started. So, we work with anyone, but at the same time, it's different clients have different needs on that too.
Right. Oh, and I just noticed in the chat that Francois kind of clarified his question about drilling fluid damage. He was specifically talking about barite. And yeah, that can be a challenge if it plugs up permeability and porosity.
Yeah, for sure. I think that's, if we're suspecting something like that, let's do that, some compatibility testing up front and see what that looks like. And, basically determine that before we go out and actually take production tubing out and cleaning out the well and then doing these things.
I think this is a huge opportunity at this point because, and here's what I'm thinking, with the mergers that are happening or going to happen potentially, and a lot of consolidation in the industry, it means that a lot of people suddenly are thinking that their certain parts of their portfolio are not appropriate for their scale, their size of operation, so they decide to divest. Well, when you think about evaluating, say, a property or portfolio or asset group, then you look at the different wells, it would be interesting to see how many are underperforming because of formation damage. And then if they are, that's like an easy win. You can go in there and just clean up all the wells.
Oh, definitely. I think we're working with several groups that purchase larger inventories like that, and you buy a wellbore at a PV10 or PV something, and based on whatever production is doing now, and if there's production you can add back there, then that's a lot of added value to a wellbore. So we have several clients that are looking into that quite opportunistically, and then to see how we can exploit the stuff they bought and be targeted on that in terms of reviving some of that production.
Well, that's great. See if you have any more that came in. Oh, here's another one. Formation damage is a zone of reduced permeability within the vicinity of the wellbore skin as a result of foreign fluid invasion into the reservoir rock. How do you pick the right treatment based on the skin factor?
Yeah, I think that ultimately is not done by us, right? That is done by that will be done by a lab or sometimes an engineer at our clients. I think for us the important thing is that we determine that we yeah, but that will be probably a little bit outside of our expertise.
Okay, and then finally, this is probably the last question. What has been your most significant operational headache?
It was before we figured out how to prep these wells before we run an isolation system in. I think looking at our track record, there's really pretty sharp difference before and after we figured out the wellbore clean out. And so that was running into wells that had kind of been cleaned out but not properly. That caused it to get hung up and initially, and it caused some headaches there. Once we figured that out how to do it, these operations become quite smooth. So that was probably been by far the biggest one.
That's great. Yeah, that makes sense. Well, this has been really wonderful. I really appreciate the opportunity to ask a lot of tough questions and also to just really learn about how to optimize assets.
Yeah, no, really appreciate the opportunity, and also everybody tuning in to the questions. It's been really good.
And I just want to remind everyone that you will receive an email with a link to the recording, probably Thursday or Friday, and it will be and also will give you a chance to kind of think over these and watch it again. And if you have questions, we've got the contact information in the final slide. So it's really good. But thank you again.
You guys.
Thanks everyone. And just, oh, when do we have another Q&A? Let's see what the question is. Oh, it just says thank you. Well, at any rate, this is fantastic, and I want to remind everybody that is just to check your email, and really appreciate your being here. Bye, everyone.
Thank you, Susan.